This is the continuous variable engine, CVE. It takes proven mechanical systems and amalgamates them into one hybrid combustion core. The linear pistons ride on rollers sandwiched between two opposing sinusoidal cams held by the carousel assembly. The quantity of undulations of the cams dictates strokes per revolution. It all sits on lead screws driven by stepper motors which control the compression ratio. An electric motor powers the supercharger. Linear pistons surround an electric motor generator that controls stop-start, region braking, and reverse rotation. The exhaust has an axial flux motor generator turbine. The carousel assembly interacts with the flywheel that leads to the drive shaft. The intake plenum liquid cooling keeps the boosted air dense for power. Piston and PMSM liquid cooling exist in the block. The exhaust plenum is liquid cooled with separate thermoelectric generator cooling around it. Each cylinder has a diesel injector, a petrol injector, a gaseous injector, a spark plug, and a glow plug. Exhaust gases hit the turbine for energy recovery. It then flows to a butterfly valve that routes it through either the diesel oxidation catalyst or the three-way catalytic converter. Each valve has its own linear actuator, static and active electromagnetic coils, springs above and below for compression and decompression with electromagnetic softening to catch the valve before it seats. An armature in the middle connected to the valve that opens and closes in milliseconds. Because timing is decoupled from crank angle, the engine can run clockwise or counterclockwise. That is your reverse gear, and it can run at 4,000 revolutions per minute in four-stroke mode, well within theoretical thermal limits. Some proposed peak calculations of multi-fuel capability. It lists various fuel types and blends the CVE can attempt in relation to cycle. Two-stroke mode creates maximum power. Four-stroke default for all fuels. Six-stroke adds two air-only strokes for internal cooling and scavenging. Eight-stroke split cycle deactivates cylinders in sequence for maximizing economy. The CVE picks the stroke to stretch each liter, two-stroke for power, eight-stroke for cruise. Experimental random mixes show what radical fuel blends can be created and the peak abilities associated with these cocktails. Multi-fuel plus blends with range analysis shows optimized versatility in various driving regimes. This omnivorous engine can devour multiple fuel mixtures of same types within a single fuel tank. Displayed are different potential mixes that can be created. The CVE component list is lighter than a comparable diesel hybrid because you remove the crank, cam, gearbox reverse, and throttle body. Different fuels operate at varying revolutions per minute depending on compression ratio and cycle. The valves enable this. They open when required, not when a cam lobe says so. Valve lift and timing profiles tell the story. Individual cycles utilize varying opening and closing durations while lift controls the breathing. Two-stroke on diesel blends is quickest. Four-stroke sits in sports car territory for most liquid fuels, and six- and eight-stroke get progressively slower as you move toward gaseous fuels. Two- and four-stroke run single intake and exhaust events, while six- and eight-stroke add a second set of valve openings for internal cooling and scavenging. The CVE incorporates high-grade components to function in the extreme conditions of its own creation. Varying fuel types require components optimized for the harshest corrosive fuels. It functions within a 4 to 16 cylinder construct, holding length while growing in diameter. Power and torque climb with displacement with peak efficiency being identical across the whole family. The matrix pairs 5 CVE sizes with matching vehicle weights. Fuel consumption rises as the vehicle gets heavier with reduced aerodynamics. 78.5% part commonality, 31 of 40 parts shared across the family. Only the engine block is unique across all 5 engine displacements. The CVE is more expensive to manufacture than conventional designs, but sharing components across 5 engine displacements narrows the cost gap. On paper, it exceeds existing car models at peak numbers when energy equivalence is factored in. EV charging rates are calculated at combined peak and off-peak times. It incorporates the same 3 electrical architectures on a shared high-voltage bus across the family. The main PMSM covers drive and region, the SRM drives the supercharger for boost, and the SSAFM turbine flips between generating and scavenging. Sustainable fuels are placed into 4 fuel types, and it can manage these blends within specified containments. By envisioning a domestic pathway and producing 15 gigaliters of renewable fuels, the CVE runs on fossils today and shifts to renewables tomorrow. In conclusion, the ability to choose how your engine runs, performance versus economy, and what you burn, renewable or not, should be a personal choice. Price and accessibility matter. The CVE inherently and continuously alters its functional parameters during operation. It allows one design to transition through ever-changing requirements. a continuity technology that lets domestic transport decarbonize using its own crops and waste streams without crippling the power grid infrastructure.